We are working with the Python third generation, which is 3.7. And so far, we have seen what is keywords and identifiers. It's very basic we have covered. Okay, it's not logical something. This is a ready-made function, inbuilt functions. We're using these functions to understand how to apply them in a cell in a Python working environment. Okay. Then we have seen comments and multi-line comments. We have seen comment, multi-line comment. Then we are into data types. Different Python data types we have seen, such as numbers, list, tuple, set, dictionary, input, output. So input output means how to format your answer. And currently we are in operators. So we are talking about this particular point here, how different operators we have in Python. Okay, so this is our current agenda. This is our 2 days agenda to see, and couple of operators we have seen, like basic operators. We are into special operators today. So special operators, the last part, sixth. Till this we have seen. Till this we have seen. We'll see special operators, and it has a two subcategory. It has a two subcategory. The first category is identity operators. The first category is the identity operators, and second is a membership operator. So these are the operators name, but what these operators are doing, that we'll see an example. And identity operators, whenever this question comes in mind, there is a two different operators, is and is not. So any element, if you want to check whether they belong to that particular class or type, you can use identity operators. Membership operators example, I'll give you guys, do not worry. This is just a name. How we are using, why, where we are applying this, we'll see. Membership operators, we have two, in and not in. So can we remember this for English word, right? Let us scroll down and and see this operators. So this is the identity. I'll just quickly cover because yesterday we have seen this, how it works. A is equal to 5. Now this 5 is an integer, b is equal to 5.0. This is a float. And technically I'm saying here that 5 is not 5.0. 5 is not 5.0, which is right. Because integer and float both are different. That's why the answer will be true. And if I check their address is different. A5, this has stored somewhere in a memory location, and that memory location is 437298, 9280. So I'm taking this value from here, and a is equal to b is equal to 5.0. B is equal to 5.0, the float value. This we have stored it 4404. So this is internal address taken by your system. You're not writing that I want to store at this place, right? And then we said this is an individual element, right? You can see just one value is there. I can call this as a scalar, right? This is just one. I'm not writing bunch of a statement within this brackets or within this brackets or within this brackets. These are your iterables. And by notation, we know this is a list. This is a tuple. I'll revisit this chapter. I'll again revisit this data type with the different functions. So do not worry what operation will apply in this list, and how can we use our tuple. This is set and dictionary both. So I'll revisit, trust me, this 4 parts. Okay, here I'm saying L1 is equal to 1 2 3. Can you see, do we have just one element or we have multiple element? So in this L1 variable we have multiple element, and the sign of this is a list. Okay, so L1 is having 3 element with 1 2 3. L2 is having again the same element 1 2 3, but we know that address of this both will not be similar. Address of this both will not be similar. You can see the address of this and this. Okay, so it's an internal concept of Python. We cannot do anything here that I can point the same memory location for L2 also. This is not in my hand. Here I've assigned 3 element for L1, 3 element for L2, but why I'm giving the same element? So that this should be very clear that if I'm working with just one element, I said A is equal to 5 and B is equal to 5. They both are pointing towards one memory. Some address is there, just like this number. This is also pointing, this is also pointing. But the moment I say A is equal to 5 comma 6, I'm taking 2 element now. Earlier there was just one, now here we have 2, and I'm using list to store this. And I said B is equal to 5 comma 6. Both are having the same element, but it will have an individual memory address. Individual memory address. Memory address 1, memory address 2. Okay, so that's clear how a list of element or number of element address works, how they remember, how they check the their place. This is so far is and is not. Then I'm checking with the string because I want to cover all the different data types. First I have taken one element, then I have taken multiple element in the list, and then in step cell number 16 I'm saying I will keep same value for S1 and S2. So I'm keeping same value for S1 and S2. So when I take this S1 and S2 same value, I'm saying S1 is not S2. In English, if I say S1 is not S2, right? Which means I'm saying this value, this is a string and this is also a string, but I'm trying to deny this statement. What I'm using here, this is my operator. This is my operator. And which operator is it? It's a identity operators. I'm saying Satish is not Satish, or string is not a string. So obviously a string is a string. Answer of this will be false, because always this kind of question will give you answer in Boolean. If it is matching true, if it is not matching false. So the answer is false here. But if you check the address of both S1 and S2, you'll find exactly same. Can you see it here? Address of S1 and address of S2, exactly same. So for one element, what is the our takeaway from here? Can we make one small note and say if element is 1, whether they belong to any data type, whether they belong to any data type. And when I say any data type, I have a list of data type. Let's revisit again. We know integer, we know float, we know string. So if element is 1 and therefrom element is 1 with just one value, their address will be similar, exactly similar, in fact, will be exactly similar. And just vice versa, if I have multiple element, whether they belong to same data type, list, set, or dictionary, their address cannot be different. So please remember this point. I'll be writing in every cell like this note, and this note is very important while coding, just as a rule. rule of thumb. Okay. Moving to the next, membership operators. And in membership operators, we have two things: in and not in. In and not in. Okay. So this is one, this is second, are the membership operators in Python. Here we said this is good to check the whether that element is present in the list or not. Okay. And this membership operators can be applied with any of the data type. You can see the sequence: string, list, tuple, set, dictionary. You can apply cross data types. Let's start from here. Variable lst is equal to this is what, guys? Can I get a quick response? This is a list or tuple or set or dictionary. What is this? What I have stored in LST. So data type is very important to remember. Okay. It's neither dictionary nor list, guys. If you remember list, I'm since beginning I'm saying this is list, right? Gaurav is right. Great. It's a set, guys. It's a set. So this sign is a set, and Bhushan, your answer is partially true, I'll say. Why? Because dictionary also we have the similar sign, but we are not only going with the sign. We're going with a value inside the sign also, right? Suppose I will insert my value in a key and value format inside this, the same sign. Okay, then it will become dictionary. Then it will become dictionary. Let's say I'm saying a colon apple. This is a dictionary. This is a dictionary. A is how do you handle the dictionary based on key value concepts? So dictionary, in other word, in other programming languages, this is also known as map, hash map, hash set, hash functions. Okay, this is a hash concept and hash table concept. Very beautiful concept in the mathematical side, and in the memory time, execution time. So as we go with the two different algorithm, we are going with the more time less space, rem space, and less time more rem space, right? So again, I'll revisit when it is required to understand and work with that algorithm. Perfect. Yeah, so this is set. And set feature we know already. This is set sign. Set does not maintain the excuse me, order, so it's unordered. Third point, we cannot access them based on the index, so can't access them based on index, because order is not maintained means index is also not maintained. And fourth point, it's a mutable. It's a mutable. You can change them. You can use insert, add, update operations. And one more point, after mutable, that they maintain the uniqueness. They maintain the uniqueness means they will identify the duplicacy and only return me the unique element. If I repeat 112 times, it will return me just one time one. Yeah? So that is anyways logically known. LST is having 1 2 3 4, and I said print 10 in list. Do you see 10 value here in this LST? Since this 10 is not present, it will return me false. If it is present, it will return me true. This is a key value pair now. This is a dictionary. So whenever you see data such as JSON, okay, I can call this type of data as a JSON, because JSON is also semi-structured or key value types of data. So they maintain the concept of key and value, and it's a universal file format, right? Across the programming language, we can use this JSON format, be it Python, Java, Scala, Groovy, C, R. All right. So a very important file format. And in machine learning, in data science, in Hadoop, in web programming, you deal with a JSON data very much and CSV data. This two data set will come like 90% times. One A, two B, one in D, one is present in D, hence I get the answer as true. So this is what is your membership operator. These are all 7 operators, okay? And we'll be using this 7 operators right immediately after this. So now we are going to understand the concept of control flow. We're going to see control flow, and this is very, very important from not from the functional programming perspective, because what functional programming says that you write all the ready-made function, you write all the inbuilt function and get the answer. Don't write so much of loops, for loop, while loop, iterables, because I can get the answer, but my objective is not just to get the answer. I'm looking for a bit of performance and optimization also, right? So when you work with the option is available, you can work with a control flow, but a strong recommendation, whenever you find there is a ready-made inbuilt functions available, do not use this, and keep this only for the critical use. Like if something is not working, the function is not available, and you want to check them, then you can apply this control flow there. And what are the options we have inside this? So we have just if statement, no else. If is statement, if it is passing, get the answer. If it is not passing, it won't return anything, because there is no else. Then we have if else. If this is not true, this is true. Then we have multiple conditions. If, elif, nested if else we can call. Then we have for loop. Then we have while loop. This is major. This is major. But two more we have: break and continue. So we'll be using this two once we understand the better one, the first one. Python if else statement. This is similar as C. Let me first write the block, then we'll go and see the operation. I said x is equal to, I said x is equal to 28. Okay, and then I said if x value is more than 20, I just give one condition. Okay, I'm using now if I read this in English, this is statement. So if is my control flow, what logic I want to use within control flow. This is my condition, and here I'm using the comparison operators, right? In comparison operators, I'm saying more than 28, and this is my condition where it starts. So this is a syntax you'll have to remember. This is what we use in other programming languages, in C, Java, and Scala, in OOPS programming. This is what we use in Python, because in Python one thing is very important. I'm going to tell you that part is known as indentation here. Is known as indentation here, and we already have seen indentation couple of times. What this indentation says, with whenever you write any condition, you cannot write the print statement or logic immediately after next to I. You'll have to take a 4 space here, 1, 2, 3, 4, and then write whatever you want to write. Or maybe you can use a 1 tab instead of writing 4 spaces. So excuse me, whenever you get indentation error, make sure there is no difficulties problem with the logic. There's a problem with your code. Excuse me, as in syntax. So no problem with the logic. This is right, this is wrong. That's why indentation error comes. Here I'll write print. Here I'll write print. The person is young. So I'm just writing one print statement, and I said this is done. when I run this, I'll get answer as young, because this is anyways acceptable. This answer, this logic is right. But suppose I just tweak this logic and say x is less than 20. Let think this. I said this, x is less than 20. So this condition is not valid. This condition is not valid, but there is no else statement. There is no else statement. This is not present, which means it will not return anything. The answer will be blank. So sometimes we see like where we are using this kind of just one statement may be required, but in order to go with the if else, we should know first how this is working. And example wise, we have taken, let me run this cell. Number is equal to 10. So I've taken one element. And then I'm saying here, if none, check this line. I'm saying if none. This none means in hard-coded condition, I'm saying that do not go to this inside this loop. Okay, don't go inside this loop. So if you see if line, and if you see very next print line, that number is positive. So do you see there is a 4 space, 1 2 3 4 4 spaces there, and then I'm writing my print statement, which means this block is one block, this block is another block. The first one, if none, this print is coming inside if, this is outside if. Okay, so when I run this, this is anytime executable. Every time this thing, will run. This will by default run, because it is not coming inside the condition. In none means don't go to this if. None means do not go to this if. It's like I'm saying if false. So if none, don't go to this condition, which means this statement will never print. This statement will never print, because it's not going to this line, right? And it is always printing me this will print always, because this condition is right. Let me change with the condition. Let me change this condition and say, instead of none, because none we know now how none is working, it's not going to that entire block itself. I want to use one condition first. Num is greater than equal to 10. Now please read the line. Number is equal to 10. If 10 will place here, so 10 is equal to 10, this condition is right. Now in this case, it will print me both. Number is positive as well as this will print always, because both the condition is right. What if I say and 20 is less than number? What if I run this now? Will I get both the answer or just one answer? Here I'm using comparison operator and logical operator combine. I've combined two different operators and calling them using the both will not come, Pallavi, if you go and see the logic. Why it will not come? Because this condition is right. The first condition is right, but second condition is not right. 20 is not less than 10, right? And since 20 is not less than 10, immediately this if condition is failed. And since this condition is failed, it will never print again this. It will just print this. Let's run quickly. Yes. So these are basic operations. There's no rocket science that we are using difficulties on this program. And these are even typical loops programming also. Can I write something else, like if I write or statement now? Any response, guys? Both. Yeah. So or is giving me or says one condition has to be true, and one condition is true. That's why I'll get both. I'll get both as answer. This is just a if statement. Now if else. So here I know in Python this coding style is very easy, but only the difference which I found personally is this. Even I stuck some time in the indentation. So please check this part, okay? This thing is very critical. Sometimes you just written 4 lines of code. Maybe assume you're writing 100 lines of code, and you're doing different kind of operations there, right? Different loops, different conditions you're creating. So this plays a huge role, and many times we need to say, because this I have my spend most of the time here in this programming. So logically this is true. Only the syntax is little bit tricky here, okay? That we need to remember how we are going to apply, how we are going to use them. If else statement, second one. Here my if first condition is not true, if condition, I'll not write the typical syntax and all. I'll give you real time block expression so that things will be easily clear. Now I'm saying age is equal to 54, and I'm giving if condition, if age is greater than 50. Okay, or maybe let me write little better statement. Age is more than 50, or or 60 is more than age, then print me. So assume it 4 space here, 1 2 3 4, and then I'm writing print statement, and in print statement I said 50 in between 50 to 60, so old. Else print senior citizen. Senior citizen. So it will print the first one, old, because both the condition is true. This condition is coding concept, we know they check line by line. So they will check this, then they will check this, then they will check this. Since this condition is satisfied, they will not go to this, right? This is like exception kind of block, you can say. When first condition is not true, second condition it will check and print them. This we are going to see how we can use an if and else. So here I have written one statement, and I'm using just a comparison operator. I'm not using even a logical operator or multiple statement. I said number is equal to 9. If number is more than equal to 10, so positive number, else negative number. So according to this condition, the if condition is filled, 9 is not greater than 10 or equal to 10. So it will print me else. This is how we can use if else. What if I give you nested if else? What if I give you nested if else? Just like this. Number is equal to 1. Number is equal to 1. Number is greater than 0. That's right. 1 is greater than 0. This condition is right. It will print me positive number. L if number is equal to 0. No, this is not right. It will not go there. It will not go there as well. It will just print me positive number. Or can I make a little complex statement? I got a guy, a student, whose mark is 83%. Okay, in state board exam, there we got the result, and that result of marks. The one guy Let's say the guy name is Amit. So this guy mark is 83, and now I want to see the grade of this guy, whether he belongs to grade A, grade B, grade C, grade A plus plus, and likewise till grade D, right? So I wanted to write one statement and wanted to check this value. So already I have one chart. Already I have one chart, which is a school chart, and in that preschool exam answer chart, I know if somebody is getting, I know if somebody is getting more than 90. If somebody is getting more than 90 marks, so the person is A. Uh, so there's one question from Bhushan. While using else if syntax, if first condition is true, then still other condition will get. No, no, Bhushan, no. When one condition is true, first condition is true, it will return me the first condition answer. It won't go to the next line. In this case, I have just given that it is wrong, but if I'm running this in my cell, it will check this. If first condition is true, it will immediately print me the answer. It won't check the second one and third one. So what I'm saying, if marks is 90, more than 90, I'm saying grade A, or let's say grade A plus plus. If mark is more than 80, more than 80, okay, and one second, because I wanted to increase this cell. So I have got this chart, okay, and this chart is telling me the grade. So this is grade, and this is the marks, or interval, marks interval. There's one more question. Okay. 80 kilometer, sorry, 80, more than 80, and less than, and less than 85. So less than 85, or maybe less than 90. Okay, let's say, so that it completes the condition less than 90. It is A. Then more than 70 and less than 80. I'm coming quick, guys. I can see a couple of questions. Let me just complete this thing, then I'll see your questions. A, B, then more than 60, more than 60, and less than 70. Then C, and last one is a D. So more than 50 and less than 60. A very basic plain condition. Okay. So looking at this chart, I wanted to create one. I wanted to write one program. Yes, Pallavi, we are using else if for multiple conditions. It is working as a else only, but suppose I wanted to check 4 conditions. So in using just if else, I cannot check 4 conditions. That's why I'm using LF concept. But logically, their internal behavior is same as else. Okay, how they're checking what answer they're printing me. So I wanted to write this, and here I will write next to this line. And exactly I'll be using this within my condition. Exactly I'll write this, what is written next to A, B, C, and D. So if mark is more than 90, mark is more than 90, print me A plus plus. First condition. Earlier you said else, and second condition. So if the first condition is not true, it will get second. But I know there are 4 categories. I do not have just A and B. I have 4 categories. How can I handle this? To handle this, then I write LF. Then you write LF, else if, and what I have written in this next to A, I'll write the same thing there. 80, more than 80, mark is more than 80, and less than 90. Less than 90. Again, semicolon colon here. Whenever you want to write any print statement, any logic, please put colon. Again, print. This is coming under E category. There will be two elif. Elif. 70, more than 70 the marks is, and it is less than 80. Print me B. Elif 60, marks is more than 60 but less than 70. It will print me C. And I'll not write again elif, because the moment you complete this the series, complete series of nested if else, so I'll directly write else, and next to else I'll give a print statement. If none of the condition is true, this else mean if none of the condition is true. If this condition is not true, then only go to check the else and print what logic we have written inside the print statement. So in print statement, I'm saying I want to print D. Is this thing clear? Here I've only used my control flow along with the different operators, right? So this is nested if else, and the answer of this will be, which grade you guys think? Obviously the answer is A, because it will first fail this condition, it will go check the second condition and print me this. Excuse me. This is the second statement is printing. Can we give condition like if 80 marks? No, Pallavi, we cannot give that. We'll have to capture this condition in multiple. That's why we are using logical operators, and, or, and, not operator, because this syntax is not known to Python. In programming language, we need to see the syntax also. After if else, nested if else, I'm going to see the iterable, which are very important: for loop and while loop. For loop and while loop. So here I have checked it for each person age. Can we just quickly go through? Age is 49, and I said it's more than 20, which is true, and less than 30. No, this is not right. It is more than 30, less than 40. This is also not right. It is more than 40 and less than 50. Perfect. This is right, and it will print me old. It will not go to this else. And wherever you're using if and else, this colon is important. This colon is important. So this is clear. Can we see this one? This is also if else, nested if else, but some difference we have here. This is a nested statement. This is a nested statement, because here if you see in this line, here I have written if this will happen, then print me. If this will happen, print me this. If this will happen, print me. I'm not writing any condition which are inside this if. I'm not saying within this condition there is another condition. That's what I'm going to see here when I say nested if else. Okay. So line by line, number is equal to 10.5, one value, and this value is from float data type. Then I said if number is less than 0. So let me change this condition, because immediately this condition will fail, because 10.5 is not less than, it's a greater than. Let me write this way. So number is 10.5 is more than equal to 0. This condition is right. It will go and check the second condition. Now can you see, this whole is one body, this whole is one block of expression. This is one entire logic, and this is the second logic. So if the first condition is filled, then it will go to else and print me in any condition this. But if it is, this is true, it will go this condition, check, print me. If it is not printing, it will print me this. Okay, so there's a question. Positive number, yeah. So that's good. We can simulate them quickly, but let's go line by line first. Okay, because we are in very beginning of our session, so I cannot swiftly jump this. Uh, Number is equal to 10.5. 10.5 is less than, sorry, greater than equal to 0. This is true. This is true. And once this is true, it is going to this condition. This is, guys, my nested if else. And why I'm pointing or highlighting this area, because please see, there is a 4 space. 1, 2, 3, 4, which means I'm saying if this condition is true, then only go there. If this itself is not true, don't go there and check, directly print me else. Currently, second condition, I'm here. 10.5 is less than equal to 0, which is not true. Hence it will not print me 0, it will print me positive number. If I run this currently, the answer is positive number. And why positive number? I think we know now. We are using nested if else. Okay, is it clear? This is clear, because I'll be using this kind of concept very much in going forward. Like going forward, a couple of example we'll find in for loop, while loop, and different data types. So this syntax will be using, guys. So please check, there is a space 4 times, and I can say I'll just quickly say one thing here. This is my one condition. If this condition is true, it will check this condition, which is a part of this condition. If this condition is true, it will print me. This print is a part of this. If not, then it will go and check else. Else is also part of this. If this is so anyways, if this is not true, if condition is true, then it will print me else. But if the first statement itself is not right, then it will not go to this entire block and it will print me this else. So readability is clear, I think. It's easy. No huge syntax we are writing. Easy syntax we have written. And there we're writing one program to find the largest number. Very simple program. I said A is equal to one value, let's say 10. B is equal to second value, let's say 21. C is equal to another value, let's say 12. I can say here how this can be executed. I can say if A is uh, greater than B, then print me something. I can write anything here. If B is greater than C, then print me something. And if C is greater than equal to A, then print me something. So likewise, when I'm comparing one by one, I can make a different combination here, A, B, C. And in a single statement, I can write two conditions using logical operator and find out which one is the biggest number in A, B, and C. So you can see the answer here, that this is the biggest number. But how to check this? If I have stored this in my memory, in my Python memory, so how I'm going to check this? How I'm going to compare this? A, B, A, C, B, A, B, C, C, A, C, B, right? So multiple condition can be there. I think if I check for this, this 3, so total number of condition which I'm going to create is 3C2, isn't it? So 3 factorial, 3C2, this is a permutation, combination, combinatorics in a statistics concept. Once we complete the Python, then we'll go to see this mathematical approach. This is beautiful approach. And this is what we need to understand how to achieve this using Python. So Python is just one language, guys, which is driving you towards this mathematics, that how you can write this maths approach in Python. But Python is just a language. There you're not building any logic. Your logic is building in mathematical side. Okay, remember this. 3 factorial. So if I know the formula of this 3C2, this formula is coming from, let me write here, this formula is coming from NCR, isn't it? N is my number of total trial and R is my chosen. So it's like N chooses R. N chooses R, and the permutation combination formula, N factorial, R factorial, N minus R factorial. This is what I get. This is what I get. So if I apply this, if I apply this formula here, what answer will I get? 3 factorial divided by 3 minus 2 factorial, which is 1 factorial and 2 factorial. And 1 second. And 3 minus 2 and 1. So answer will be 3, right? 3C2, answer will be 3. So we have 3 numbers. That's what we have, these 3 numbers, but different combinations when I'm going to see. So different combination wise, it will be 6 different combinations, right? A, B, you can see the combination A, B, A, C, B, A, B, C, C, A, and C, B. This is what I'm going to check individually. Let's go and check. Last one. Number is equal to 10. Number 2 is equal to 50. Number 3 is equal to 70. I've given random number. Okay. And I can interchange for you. If you're thinking that I want to get the highest number using, maybe I place this 75 here and I want to print number 2 as a 70, number 2 as a biggest number. So how we will do that? Nested if else. Yes, Gaurav, we can use the nested if else also. Look, when we are working in a programming, one answer we can achieve using 10 different approaches. Yeah. So it's not that this is only the answer, this is only how we can achieve. We can just use if and elif condition also multiple time to achieve this. Okay. So we need to see 2 things whenever this kind of question comes, that we can write this program, that program, this logic, that logic. So first always think about number of lines. How many number of lines of code you're going to write in Python, and second, what is their total memory optimization, like how what is the size of the function. Like if I'm creating a function, if I'm creating a logic, what is the size in terms of bytes? So first I'm checking number of lines, second I'm checking this, then I'm writing the code. So if we maintain this 2 thing, trust me, your code will be written well, logically understandable, readable, and it is optimized already. So we have reached to the optimization. It's like, so one question, there can be 10 different approach. There can be 10 different approach to get that. And we need to use this smart and easy way. Okay, fine. Now let's go and see the program. So number 1 is equal to 10, 2 is 50, 3 is 75. I'm going one by one. First condition, and this is my if elif condition. 10 is greater than equal to 20, sorry, 50, because my second value is 50. 10 is greater than equal to 50. This is wrong. The moment you know wrong, and then you immediately read the next operator, which is AND operator, logical operator. So immediately you say this condition is failed, because AND operator says both the condition we need true, has to be true, both the condition, right? Since first condition is failed, I'll immediately say this if is not going to execute, and hence I'll go to the second condition, which is elif. In elif, I'm saying, so I'm writing this values next to this. I'm solving this block first. Number 2 is greater than equal to number 1. 50 is greater than equal to 10. This is satisfied. This is satisfied. And number 2, and number 2, which is obviously 50, is greater than equal to 75. This is not true, which means this condition is also failed. Else, the largest will be number 3. And what is number 3? Number 3 is 75, which means largest is equal to 75. And then I'm printing this saying, I can say directly print me the largest, but say, I'm adding one statement so that this looks little easier and good to read them. Largest element among 3 numbers is format largest. We have seen this format thing yesterday. It will place value 50, and this largest index is 0. This is 0. So automatically this value is mapped here and printed as this. Largest element among 3 number is 75. So is this clear? Is this thing is clear? I've just compared the numbers, and you can manipulate them. Like, let me. It's not ready-made written code that if we cannot change anything, I can place any value here. I can literally place any value here and see how they'll check. Let's not go and run this command directly. Let's go and see how they'll execute it. So first condition is anyways wrong. This condition is wrong because 10 is not more than 78. So this itself is wrong. This condition itself is wrong. Second, I'm going and see. Number 2, 78 is more than 10 and 78 is more than 57. Logically, the answer is 78, and it will print me largest is equal to number 2. Again, it will come and say 78 is a largest number. Okay, so this is how it will work. In this cell, in this 0.6 cell, we have seen if condition, we have seen if else condition, we have seen if elif condition, we have seen nested if else condition. Nested if else condition. Now we're going to see the iterable parts. So these are working. One thing, we are seeing how to use them, how to call, how to combine using operator, different kind of operator. But again, remember, when I have one element, when I have just one value, then I'm using this condition. So far you have seen I assigned one value to one variable. I assigned one value to a variable, and in my above step also I have assigned one element to a variable, and then I'm checking this if else, if nested if else, if, right? Again, only one thing to remember, we are only dealing with one element, so I'm using this if else. What if I have multiple element? What if I have bunch of element, like 10 elements in a bracket? That bracket can be list, tuple, set, anything, but I have multiple elements. Maybe I have 10, 20, 50, 70, and this all I have stored in a variable called a. All I have stored this in a variable called a. So a is equal to this, and let me store this in a tuple. I store them in a tuple. This sign is for tuple, guys. I cannot use if else here. There, like, you can use a different logic, right? Different lines of if else. You'll have to write so much code here if you want to work with if else. This is not logically true for if else. Whenever I see multiple element, okay, please focus here. When I see multiple element, I consider that this is coming under iterables. This is coming under iterables. I need to deal with all the element one by one. This one, this one, this one, this one. If I read based on the index, I'll say this is my 0th index, this is my first index, this is my second index, this is my third index. If I check the length, I will say 4. 1, 2, 3, 4. This is my length, right? And I want to deal with this iterable. So we need to know two different control flow, which are very, very important: for loop and while loop, and extremely useful in a real-time applications to deal with a multiple. Like you'll be using this in Python libraries, NumPy, pandas, and a couple of machine learning applications. Tremendous. This is good approach to apply get answer and not use so much of functions. But again, when you are working with a functional programming concept, Python is a functional programming language. It supports object oriented programming thing also. But always, guys, if you are able to see that function is available, it is there in the library, please use this. Don't go with this, because our ultimate approach is to go and learn machine learning applications. So in machine learning applications, you don't use so much of oops concept. You use the ready-made functions coming from different libraries. So you need to import those library, call their functions, use them individually. Okay, so this is not required. Object oriented, where we talk about 6 different principle, if you guys know: classes, object, encapsulation, polymorphism. So this is not useful in machine learning applications. We can achieve them in this. So